Everybody, say hello to LeBrick. LeBrick is a D1 college athlete with dreams of making it into the NBA. However, the only thing from stopping him is this basketball game right here. His team is down by 2 points, and there's only 3 more seconds left on the shot clock. Well, LeBrick has possession of the ball, and if he makes a three-pointer, well, his dreams might just come true. Let's see what he does. He dribbles the ball down the court, he gets an open shot, and he absolutely sells. He doesn't know anything about projectile motion, as you saw with that incredibly flat arc. The consequences of this are pretty severe. With this horrible shot causing him to lose the whole game, causing him to lose the season, the coach cuts him from the team, causing him to go into depression. Basically, his room becomes a mess, his life becomes a mess, and he just decides to jump in his grave and say goodbye to the world. Do not become a failure like LeBrick, and instead, learn about projectile motion in this video. Alright, but what even is projectile motion? At its core, projectile motion is just the motion of an object thrown in the air that's only subject to the acceleration due to Earth's gravity pointing downwards. For today, we're going to ignore the forces due to air resistance because that makes our problems way more easier. Let me quickly draw out the path of a projectile, say a basketball, that starts and stops on the ground. As you can see, our basketball goes in this curved parabolic flight that is symmetric down the middle. This means that the motion experienced on the left half is exactly the same as the motion in the right half. The only thing that's changing is the direction of the ball. The left half, it goes up, the right half, it goes down. Let's take the starting position for example. At the beginning, the ball is thrown with a certain velocity at a certain angle. Now, to make projectile motion problems easier to understand, we like to break them down into their horizontal and vertical components. So instead of having this weird diagonal vector which is pointing at a random angle, using trigonometry, we can break that vector down into its x and y components to make this problem a whole lot easier. Now, due to the symmetry, the motion in the start position is going to be the same as the motion in the end position, except they're in different directions. Alright, let's continue along the path and choose another point. At this point, our velocity vector becomes more flat. But why does this happen? Now, the definition said that an object in projectile motion is only subject to the acceleration due to gravity, which only acts downwards. This means that our horizontal motion should not change. Our horizontal component of velocity will be the same exact along the whole entirety of the path. The only thing that's changing will be the y component of velocity. Now, since our basketball is initially going upwards and gravity is acting downwards, our velocity will now become less in magnitude. Alright, let's look at one more point, my favorite, the top of the projectile. Now again, there's nothing changing our horizontal motion, so our velocity in the x direction should be the exact same. But what happens to our vertical component of motion? Well, at the top, it's actually 0. This is the point where our basketball basically transitions from going upwards to now going downwards. Gravity slowed it down enough, and now gravity's gonna pull it down back to Earth. So at this point, our velocity vector is just the horizontal velocity. Now let's see if we can use this information to help LeBrick not break his shots anymore and maybe give him another chance at living his dreams. Let's go back in time to that basketball game and take some measurements. Typically, the height from the ground to the hoop is going to be about 3 meters. The distance from LeBrick to the hoop is about 6 meters when he takes the shot. And the distance between the ground and the point of release of the basketball is about 2 meters. Now I know I'm not the best drawer and this picture isn't exactly to scale, but hey, we're worrying about the wrong things. We're trying to save LeBrick right now. So bear with me, let me land the concept. So what angle should LeBrick shoot the basketball? Well, if he did a simple Google search before the match, he would have known that 45 degrees is the optimal solution. So let's force him to do that. Using the information we now have, we can calculate the initial velocity that LeBrick needs to shoot the ball to swish it in the basket and win the game. In other words, let's use some physics to save the day. Alright, just like other physics problems, let me draw a quick schematic to kind of visualize what's going on. Now that I have a quick sketch of what's going on, we can go and figure out that initial velocity. Since it's so hard dealing with these diagonal vectors and trying to do calculations with them, we're going to break this problem into 2 parts. The x component of motion and the y component of motion. And at the end, this will allow us to figure out the initial velocity in a more organized manner. Let's start off with the horizontal component of motion. Now, since we don't have acceleration in the horizontal direction, we can use the concept of average velocity to describe the horizontal motion. This means that our horizontal velocity throughout the whole path is just equal to the change in position over the change in time. Now I know you're stressing out, Einstein, but we don't know how long it takes for the ball to go into the basket. That means we can't solve this problem. But there's no need to worry. I got a few tricks up my sleeves that'll allow us to overcome this challenge so we can solve this problem together. But first, let's talk about the vertical component of motion. Unfortunately, this will be a bit harder than the horizontal motion since now we have this acceleration due to gravity acting downwards, but using the kinematic equations, we can solve this problem. These kinematic equations help us describe the motion of an object that's subject to a uniform acceleration, such as gravity. Now for this problem, all we need to use is this specific equation right here. Now deriving these equations are super cool, but unfortunately, LeBrick's life is on the line, so we'll save that for another day. Since we're dealing with vertical motion, we have to make sure our variables correspond to that. So the basketball starts at 2 meters high and then ends in the hoop, which is 3 meters high. So our change in our position in the y direction is only 1 meter. Now for acceleration, we're going to be using the acceleration due to gravity. And to make things easier, we'll make it negative 10 meters per second squared. Now we have two equations we can use, one describing the horizontal and one describing the vertical direction of motion. But that's not exactly what we're solving for. All we want to know is the velocity that LeBrick needs to shoot the ball to make it in the basket. We don't really care about the components. So let me rewrite both of these equations in terms of the actual initial velocity. But to do this, we need to know a little bit of trigonometry, but let me just draw it out. We can now insert these two expressions into our variables from before. Okay, we're making progress. We have two equations, but with two unknowns. We don't know what the initial velocity is, and we don't know what the time is. But this is where the trick comes in, and this is the power of algebra. If we were to take this one equation to the left right here, and isolate it in terms of time, and then take the time and plug it into our second equation, well, now we'll just have one unknown with one pretty complicated equation that we can just use some more algebra to figure out. All right, now since we have a V0 in the numerator and a V0 in the denominator, we can just cancel them out. And also in trigonometry, sine over cosine is just tangent. So we can go replace that in the equation. All right, now this is turning into a scary equation, but we want to isolate for V0. So let's bring out this and take it to the other side just to leave this little goop of information by itself. Next up, I'm going to multiply this expression by each side. And to finally isolate V0, I'm going to divide each side by this mess right here. And lastly, we need to take the square root of each side. The last thing that's left to do is throw this crazy expression in a calculator and figure out our initial velocity. And after we do all that, we see that the initial velocity should be about 8.49 meters per second. All right, let's go back to LeBrick and give him one more chance to certify his glory. But this time, he has the knowledge of projectile motion. Let's see what happens. Same scenario, he's dribbling down the court. He shoots, what a beautiful projectile. He swishes that goal and wins the game. But what does the future hold for LeBrick? Well, ever since he learned about projectile motion and drained that shot, he's now extremely happy. He's generated immense amount of wealth and bought a new mansion. He even started a beautiful family. And he went on to become the legend as we know him today, LeBron James. So I hope this video taught you about projectile motion so that now you can go establish your own legacy. I wish you the best of luck.